long times, and Fateh is trying to. See. I'm not sure, Fateh, if people just wait. Yeah, 20 more seconds because there's a latency. Please take your seat. It's been long times, and Fateh is trying to. Okay. Hi, everyone. It's good to see very new faces as well. I am meeting a lot of you guys for the first time. Just to introduce myself, I'm Khan, and I'm Cloud Solution Architect in Data and AI. And I have my other colleagues, Sarmad and Fateh, and another Sarmad as well. We are all here as Azure developer community. So we will be running these kind of sessions frequently. You guys are welcome to present as well because it's like an open forum. Anyone can present their experience, share with others. So we are like, you can follow up. And what we will be trying to do in this series, we have planned 6 weeks of series for AI learning. So this is the first week, but I'll just show you the agenda for the next week, and then you can attend probably the next 6 weeks just to have an end-to-end. So what we will be doing in the first one, this will be an introduction session. People who are not aware of AI or like OpenAI or how to do this. So we will be first doing like the intro. It will be setting the foundation. Then in the next week, we will do the prompt engineering and what that topic is. We will cover a few more items. Then we will do building AI applications. It will be mostly on the application on the front end, how you can create an application which is AI driven. Then we will build an end-to-end architecture, secure architecture, how you can deploy it. So once we build this whole 4 weeks, then we will start working on deployment. And the deployment, what we will do is we will do infrastructure as a code, probably with Terraforms or ARM templates, how you can deploy this in your own environment. So it will be a good experience that you can do it securely. And the last session will be on other large language models or small language models like Mistral, Llama, Phi3. So we'll discuss those topics as well. And then if you have any more questions, we can do that accordingly as well. So any questions? It will be every Tuesday, hopefully, and at the same time. And Fateh, and we will give you pizzas as well. So just to keep you motivated to come to the office and meet us. Okay, so just wanted to check, like, you will heard a lot of like these acronyms, AI, ML, BL, generative AI. Who is familiar with that? Do you guys have an idea what these terms mean? Anyone? Yeah. Can somebody tell me what is the difference between AI and ML?
ML is machine learning. So this is whatever the engines that you will have to learn your engines to do some certain actions based on the data that they have.
So I'll just give you a few definitions, right? So in here, what you can see is that AI is the parent word. Okay, AI, everything is AI. Okay, and then there is specific algorithm which you can do. So there is then a branch which is we call machine learning, in which you have like some training data. You just train it like classification, clustering, forecasting. You have this kind of models, and you just like use that algorithms accordingly. Now, most of the machine learning algorithms were such that you have to give features. Features, for example, if I ask you that you have an image or you have to identify a number. Okay, a classic example, you have a number and you have to give that. So you will have to identify how a number is written, how many curves it has, whether it is just straight or there is like round curves and things like that. So you have to give that features. Okay, the image cannot do anything directly. So machine learning is the classical way of doing it. And then we have deep learning, which the algorithms are based on the human brain, how the human brain works. There is neurons, and the neurons are connected to each other. So you can do classification or complex tasks like image recognition or natural language processing. These algorithms are more compute intensive, and because of the cloud, Now we have a lot of compute power in the cloud, so you can run these algorithms and it become more popular nowadays. And then, so these are like, for example, this is the superset is AI. Then under that is ML. Under that is deep learning algorithms. Okay. And under that, now we have generative AI. So what generative AI is a subset of like the whole area. But essentially what you do is, it is just a completion. Okay. You ask something and it complete or predict what is the next word or what is the next item. Okay. So on text, specifically on text part, if you ask it twinkle, twinkle, it will see a little star. Okay. And you can try that out because it knows how to complete a sentence. Okay. If you just say, what is the capital of Qatar? Okay. It knows this question. It doesn't know what is the capital of Qatar. It just say that how can I complete it? And the completion is, it will say that the capital of Qatar is Doha. Okay. So it's just like generating some new information based on what you have provided. Okay. And it can do it something from its memory and something else that we will discuss as well. Now, most of these, like if you see this I put some tools in here, but these are some of the technologies which you can use in Microsoft or Microsoft Cloud to create new models or use the existing models that we have. On the left side, you can see like what is we call cognitive services. Cognitive services are pre-built or pre-trained models that you can use and you can start calling them from your application. Like for example, if you are translating language from one language to the other, or you are seeing in the text whether there is some names or addresses or numbers written, so you can use this rather than creating your own models from scratch. You can do this directly. Okay. Similarly, like AI vision, rather than like asking you, okay, if you take a picture and ask, for example, what is this picture, like a plant or something. Okay. Rather than blending your own models, these models are pre-built. Okay. So you can use like OCR. You don't have to build your own OCR because this is already like quite advanced research area. You have already the models. You don't need to start from scratch. You start from this foundation and build on top of it, like more intelligent application rather than creating everything from scratch. Okay. Then the speech to text, text to speech, translation, and everything that is covered in that area. On the other side, you can try to create your own models, like from scratch. Okay. So you can use like Azure Databricks, you can use Azure Machine Learning to bring your data sets, create new classification or clustering models or forecasting, and then you can like create your application or call them from your application accordingly. On the top, I have put like Azure OpenAI because that will be primarily the subject, and that's what we are going to do. But it's just to put you everything what we are going to cover. Okay. But the top part, Azure OpenAI, and just to ask you guys, what do you think is the difference between Azure OpenAI and the OpenAI or the Chat GPT that you have in public? Do you know what the difference is? So just to let you know, right, like you will go to the Chat GPT, like the open source or like the open platform where you can ask the same question. But what Microsoft has done is we have partnership with OpenAI. We have taken the same APIs, the same models running on Azure, and we have put security and compliance on top of it. Responsible AI that you cannot ask harmful questions. Okay, it will have a governance in place. It's an enterprise ready rather than for the public. Okay, so just consider it that way. And it's running on Azure. Like, for example, if you are a big company, you want your own models to be running in your own isolation with the control that this data, whatever you are asking, is not going out of your corporate. Okay, so those compliance boundary, when we call it, that is running, that is called Azure OpenAI. But the APIs, the models, everything is the same. Okay. Okay. Now, one question: if there is a new technology, okay, what do you think the reason is that somebody will adopt a new technology? Why would someone, like, for example, when Azure OpenAI came, why do you think people are adopting it?
Because there is a need.
Yeah. And what could be the need?
The Gen AI use cases and OpenAI use cases that we are having these days, OpenAI can complete those use cases.
And when we're saying the needs, like, for example, there is a need, but what is the benefit of that need? Like, when that need is fulfilled, what can happen?
Yes. Safe environment to host my
Maybe different thing. Okay, so I'll just put like just not an exhaustive list, but as we mentioned, right, that there is a need, but the need can be in different way. That why you have a need? You might be improving efficiency. Okay, you want to, like, you have some processes which are not improved, or you are having, let's say, a classic example, a call center, but you are always like human sitting there and answering. You want to automate this, that so people can, the system can automatically reply to it. Okay, so that's one need. The other can be saving cost. Human is very expensive resource, right? Like if there are 100 resources sitting and doing like manual work, but you can offload to computer, that can be another thing. That you save cost in a longer run. Okay. The other thing can be competitive advantage. If one company is doing it, if I'm not doing it, I'm at a disadvantage, right? This is another thing that people will adopt to new technology. One other thing is forced because of a law or legislation, right? Like you have heard about GDPR, why people are doing it. There can be a law that you have to do this or adopt to this technology. Okay? So that can be the other thing. The other can be status, right? Status can be another thing. When new things are coming, people wants to be more trendy, right? Like they like to adopt to a technology more. Okay, like a lot of people think that iPhone is a trend, right? Like it's if you have it, like you are more trendy or you are like in a high class or things like that. Okay, so it's like a perceived status. Like everyone has a different perception. That can be one thing as well. Everyone wants to do something with AI. They might not know what to do with it, but they want to do something with it. Okay, or maybe social influence, right? If one, let's say, if you are in a competitive industry and you have somebody else has adopted it, you want to adopt it as well because you don't want to be left behind. Okay, that can be another thing. The other is fear to left behind as well. Like a lot of time when these new technology come, people adopt it and then they are so far ahead that you feel left behind and you don't want for because of that fear you want to adopt new technology. Okay, so this can be some of the reasons that why would we need it. Okay. Now, with AI, like as you know, like there is different. It's the same information. I'm just repeating a few times before going technical, but the AI, you know that it's applicable in each and every business, right? You can have an impact on every individual. Okay, individually, like if you see your phones, it has some AI built in. Okay, like your calendar, how to manage it. You are asking information, so that is improving your own productivity or saving you time personally. Okay, processes as well. Like if you have some processes, like the call center example, we have that rather than like calling each time a human person. If the machine can adopt or answer that common question frequently, you might not have like human all the time sitting there, and you can use the human brain for something more intelligent. Okay, and organization we have already discussed. Industry like in medical field, in banking, everywhere we have the adoption of AI. And how these are doing it, like you as an employee, right? Like if you have one of the common example is that you will sometime get locked for the password. Your password would get locked and you have to call someone. Now if you can reset this password automatically, I'll give an example that I was working in Australia with one of the retailer, and they have a bot or AI model in which they just have to return, like if you place some order, let's say from Carrefour, and the order has some item which is not delivered, or the item is not to the quality that you want. Okay, so millions of dollars were just spent for this calls to refund the money. Okay, and they have just built one purpose bot that people who have got an item delivered and they are not happy, they can just ask for refund. If it's below $30, it will automatically be refunded, no question asked. And they save millions of dollars just by using this information. Okay, so you can build this kind of information, improve the processes, and have the customer there. Now, what I'll do is I'll go now to a technical part. Okay, there will be a bit of mathematics, but I just want to appreciate that whatever you have learned in your high school or your university, that is all AI. Okay, so do you recall what a vector is? Okay, you would have learned it in physics or calculus or mathematics. Okay, so this is the basic thing. We will start today with vectors, and all my discussion will be on vectors, how we store it, how we create it, and how this can be used for AI. Okay, so the basic definition, if you remember, there is two types of vectors. One is geometric and one is algebraic. In geometry, you have the dimension and you have an angle. And the other one, you have an ordered pair. Okay, And just remember this formula. Okay, this looks scary, but it's like from your basic calculus. Okay, you have these two formula. Okay, and I'll come to it how this is implemented or how you can use this in the cloud. Now, the basic thing is when you have two vectors, okay, you have two vectors, vector A and vector B, and you want to find out whether the two are similar or not. Consider that you have 1 million vectors and you have a new vector that is coming and you want to find out which is the closest to that. Okay, so that's the formula. Okay, you just find the angle, okay, which is a dot product and the norm. This is again from the basic calculus. This is the formula. Okay, and I'll show you exactly the power of this, how you can do this with all your AI. Is just this is the foundation.
But one question here.
Yeah.
Do you do that with every vector that is nearby?
Yeah, I'll show you how, because when you look into this, you think that a brute force approach, right? You just say, I have to do this for each and every one. But when you look into technology, how it can be done at a set operation and how this can be done at scale, that is where the power will come in. Okay. Now the second topic which I want to introduce. Okay, we cover vectors. Vector is just an ordered pair of numbers. Okay, what is embeddings? Okay, embeddings is when you have a text or an image or a video or an audio, you convert, give it to some function, and you get an output which is a vector. Okay, and the power of this is that there is meaning to that. Okay, that number has a special meaning. Okay, like what it represents. If you give an image and the image has a car or a dog, it will know that if you give another image or you ask which are the images which has a dog or a cat or a car, it will automatically know. Now, how this happen? That is the research topic. Okay, but I'm just saying like, that this can happen. And why I started with this? Okay, the embeddings has a lot of applications. Okay, it's not just for AI, but a lot of application in searching. Okay, so as we discussed, you have a large set of data or images. Let's say how Bing uses it. Okay, let's say you have a retailer who are selling furniture. Okay, or I'll give an example of Fateh. Right, Fateh has very good office in his house, and if I like it, I can take a picture of that chair or like his setup and ask whether I have this item available. Let's say in IKEA or some other thing. I doubt it will be in IKEA, but I'm just giving an example, right? And from the images, you can identify what is the closest images to that. So rather than you describing the object, you are using an image to compare it. Okay, let's say you like my shirt. Okay, you can take a picture and you can see where can I buy this shirt. Okay, so rather than explicitly coding it or explicitly storing it, you are using the visual experience, and this is the similarity. You convert this shirt to a vector. Your new input is a vector, and you are comparing where can I find this shirt. Okay, so that is the searching experience. Now for clustering. Okay, clustering is a very powerful technique. You can do it in a classical machine learning as well, but consider that you have a lot of data sets and you want to find out which are the closest item. Okay, so let's say you have millions of images. Okay, or consider recipes. Okay, you have a lot of recipes or a recipe website, and you want to know which recipes has chicken. Okay, now it's very easy to say that you will just search for chicken, right? But consider that you have allergies or other things, or you make it more complex. Then based on that criteria, you can have a clustering that these items are closer to each other. Okay, or how like Netflix is doing the recommendation. There might be more complex algorithms, but at simplicity term, this is exactly like what can be done with embedding as well. Okay, any questions till now?
For embeddings, when we pass a vectors, what kind of vector would be like a geometric or an algebraic?
You just consider that it will be like a vector, plain vector. There will be numbers, okay, and there will be some dimension. I'll show you that in a while. Okay. Again, like anomaly detection. If you have a lot of like text or something, and you want to identify that there is some anomaly. So again, like if you do clustering, okay, you can find anomalies as well. So these are the different implications of embedding and why I started with this topic. Just before going into the end solution, if you look into the foundation, then you will be able to appreciate how these algorithms work, and you can think about new use cases which can be developed with this. Okay, So just keep this in mind, okay? So this is how embedding will look like, okay? And then I'll go to the actual demo, okay? So consider that you have text, image, video, audio, okay? Or a text example is what are the topics of AI series, okay? This is a word. Now, if you want to search this with something, okay? Either you will say, Sher, I will match the words individually, okay? Match the word individually, you will just like do a like query or something like that. But it might not have a semantic meaning, okay? If I completely reverse this and not have any meaning of it, it might return something, but it might not be useful, okay? And then the embedding models, there should be a function which can do this from text or image to a vector form. And this is what we will call embedding models. We will check into this one in a while, okay? And then the output will be something like this. You will have a vector, which will be like this. It will have a dimension, okay? We will start with 1536 different, the length will be 1536, okay? And when you sum this up, it will be almost equivalent to 1, okay, or -1. It will be between 1 and -1 between that. It is normalized, okay? I know till now I have been very theoretical, but I just want you to appreciate how this algorithm works, so then you can go to the next part. Okay, I'll introduce a few more concepts and then I'll go to the demos. Okay, so when you are going into Azure OpenAI, okay, there are 4 topics that you need to understand. Okay, the first is the models. Okay, the first is the models. We already covered one model, which is embedding. Okay, and embedding is simply taking some input and creating a text out, a vector out. Okay, then you have the GPT-O or DALI model. DALI is like you just give a text and it generates an image. Okay, and the images that you can say, okay, create like an image for the AI community and give a Qatari flavor to it. It will generate an image for you from the words. And then GPT-4o is what you already have in the chat GPT, that you ask a question, it will return to you some answers. Okay, these are the models. These all pieces will come together. Believe me, I'm just going to combine all the things together. Okay, then you have to understand what is called tokens. Okay, token is the unit of measure. The unit of measure or how this algorithm will perform or how this algorithm will charge you back. Okay, consider that this is the currency. Okay, if you give me a very hard task, okay, I'll charge you more. And this is the token. If you give me a lot of tokens, I'll take more intensive work and I'll charge you more. Or I'll take more time to analyze or respond to you. So just consider that token is related to that. Okay. And here I'll just now wrap it up to give you like the actual coding. But consider that embedding will just take this one model, okay, today's topic. And why would I need embedding? Okay, can you just help me? Why would I need embedding? Why would I convert the text or the image to a vector form?
It's only understand.
Yeah, very good. Because the machine only understands numbers, 0 and 1s. And if you have numbers, you can do relationships or like subtraction or addition or angles. This become very easy.
A vector to another.
Yes.
Or an input to another image to
Yeah.
image text.
But what needs to be in the same format, right? Like you cannot have that. I have a text and I just want to compare to vector. If both are vectors, then the computer can do arithmetic operation very fast, and it's very easy to then come up with algorithms. Okay, and consider the other thing. If you have heard about dimensionality reduction, okay, so I'll just go here. This is what we will do in the topic. I'll take some data. Okay, initially it will be text, then I'll go to images. Okay, we will apply the embedding models. We will create vectors, and then we will search a few vectors. But the main part is we will then go to vector databases. Okay, this will be the first topic that we will do today. And the next week, we will go to more advanced stuff. So let me now switch back to the coding. And what we will do is, I'll show Python coding, but I hope you are comfortable with some form of coding. And what we'll do, I'll just go step by step. Okay, I'll explain what I'm doing, and then we will build on top of it. Okay.
Make it white, the background.
We'll see the font.
Control or.
Hmm?
VS, right?
Yes, VS Code. How can I enable
Control or S.
Control R S? Okay. Control or S, you said, right?
Yes.
On somewhere else. Back. Let's see where I was. Now I'm lost. Just give me a few seconds so I can go back to the area.
You can go to file and then preferences.
Yes. In 1 second, so I can at least go to the actual notebooks that I was doing.
File preferences.
Yeah. Right, and 1 second. And team, I'm not like a hardcore coder. I'm just like the data guy. So that's why like some of these things will need your help. But yeah. File.
Preference down. Down. Preferences.
Yeah. Preferences.
Themed.
Just the color or what do you need?
Just like white.
Yeah.
Right, for the first one.
Okay.
Find your
Yeah. Thank you. Let me go to the recent ones. Open. Okay, and I'll go first to. Let me check if I'm on the right one. Okay. Sorry, team, if for the hiccup, but yeah, it always happen in live demo. So what we will do is, I'll take a text file, okay? I'll create vector out of it. I'll just explain the information. First, we will do all the operations in memory, okay? In the computer memory, and then we will find out the challenges which can happen with that, and then we will go to the next part, okay? So a simple thing is, I hope everyone can see it. The first is just to install the libraries, okay? So we don't need that, okay? I'll just import some more libraries which are needed. And in here, I'm just importing a CSV file, okay? I'm just importing a CSV file, very simple. You don't need to understand the coding. I'm just giving you the concept, okay? I have one text file, which has these 3 columns. There is a text, a summary, and a title, okay? And this is, I think, some information related to the US bills in their Congress, okay? So we will create embeddings on this text. And then we will try to find out how to create embeddings, because usually if you're trying to search a question, it will be very difficult to do directly on this one because it has a meaning in there. So we'll use vectors to do this, okay? So just give me 1 second. It's changing the kernel and things like that. So just give 1 second. I should have changed it, the background in the start, but I thought it will be fine. Just give me 1 second so I can have this. Any questions till now? Like if you have any doubts or anything like that, or you have questions while this is coming up, so you can ask your questions. Have you played with vectors before, like through application, or like do you think this is something I'm presenting new to you guys? It's doing something, okay? But I'll explain the code first before we execute, okay? The first thing is we are importing like some data, okay? The data in this one is like in large CSV documents, but you can have individual documents as well, okay, like separate PDFs or Word documents, and then you can convert into a structure. And then what I'm doing is, then I'm selecting just the main three columns, okay, the text column, text, summary, and title, okay. After that, I'm just doing some pre-processing, okay. Some pre-processing means that I'm just removing the extra spaces, the extra lines, the extra commas, and things like that. Just some normal stuff, but you don't need to worry about this, why I'm doing it. You just need to understand what is the concept, and then we will build on top. Okay, so let me now do this. Okay, so this is like the first three columns. These two are already processed because I've executed the code. But now, if you see here, it will be exactly the same. The three columns. Okay, and I'm just doing some processing, which is removing new line characters, extra spaces, commas, and things like that. There is a lot of these dots and things like that. So I want to avoid that. Okay, because it counts as a token. I told you token is important. So unnecessary stuff, you can remove it, which doesn't have any meaning to it. Okay. And then here, I'm just encoding the information.
And space also?
Sorry?
Between two words space also?
Say again, sorry.
Saying between two words.
Yeah.
Space also you are removing?
No, one space is okay because then you have to understand the word, right? But if there is multiple, why would I take that? I want to avoid that. And if you just without cleaning, if you do it, it will work as well. But I want to reduce the number of tokens. Okay, and I'll explain the tokens what I'm doing here. Okay, so now consider here, okay, that I'm just doing this encoding, and in here this is the code. Okay, just understand this code. There is 3 lines. Okay, I'm creating an OpenAI service. Okay, and I'm giving the key and the endpoint, and then I'm using a very simple function. It is called client.embedding.create. Okay, create is the input name or the text which is coming, okay, your query or the input that you're doing, and then which model to use. The model is the embedding models that we started with. Any problem till now? Okay.
Can we zoom in?
Yeah. Father, do you know how to zoom in the VS Code?
Control plus. It should be Control plus.
Plus, hope it's.
Or in the view menu, you go to the view menu.
Better now?
Yeah, that's better.
So in here, we're just creating the embeddings, okay? And once the embedding is there, if you see here, this is just like a function. I'm just storing it in an extra column, okay? The vector space. And if you see here, this is if I just do a head now again, okay? There is one extra column. If you see here, this is the number of tokens, how many tokens I have. And then if I go here in this one, I execute it. And you don't need Python, you can do it in any language, but I'm just trying to see how you can interact with it. I'll just show 2 flavors, one for the application guys and one for the database guys, okay? But in here, you can see that there is the vector database is created or the vector set is created, okay? This is the vectors after the embedding. And what is the total token, okay? That is the size of the token. How many tokens were used in there, okay? Now, why this token is important? In each call, you cannot have more than 8,000 tokens. Okay, so if you have a document which is very large, okay, you have to either reduce it or like create it in chunks or in pages. That is called a chunking concept, which we'll do in the next class. Okay, but now what I'm doing is I've created this. I have the number of tokens. Okay, and if I go here,
This limitation of 8,000 words, this is at the algorithm level or at which level?
So consider that if you are sending, let's say, 2,000 pages in one go, okay, the performance will degrade as well. Your questions are sometimes not on all the documents. Your question is sometimes fixed on a few pages, okay? So what we do is to balance the performance and everything together, okay? You take chunks, okay, and the chunks should be like maximum 8,000 words, and then you do that. If you have very large document, you divide it into pages. And the pages should have an overlap, so it understands which is the next chunk.
So the algorithm is designed.
Yes, yes.
We have also another question from YouTube. online. Nada is asking if there is a no-code solution for this. Instead of writing code, can we do it with a no-code solution?
Yes, that's a very good question. Yes, you can do with no code. I'm giving the example, but you can use multiple connectors. Like for example, you can use Logic App. Okay, if you want to do it, you have a lot of these things built in into some of the services, which we will do in the next session, and that can you will not have to write this. But consider you are doing a website development, okay, and you want to create your own function. So if you understand the code, it's much easier for you how the things work, and then you can use the no code examples. But you will at least understand how these things work or how these are built in. Okay, or if somebody is building it from the code, there will be always some part of code as well, because if you are writing an AI application, there will be some code involved. Okay, but it's just like calling the APIs. Okay, now I have the cosine similarity. Okay, the first function, if you remember my slide, we said the dot product of the two vectors, and then the norms. Okay, that is the same formula. This will give us the closest how the two vectors are closed or to each other around. Okay, then I have the embedding, which we already discussed, and then the search documents. Okay, so if you have the data frame, okay, the DF is considered like your whole data set, the ones which we import. Okay, that you pass, that this is now your link where to check all the documents. User query, if you are asked a question, okay, that will be the question here. And you said how many top results you want to return. Okay, because everyone might have a little bit of match. Okay, so you want to return maybe the top 4 or top 3 or top 5 based on your use case. Okay, but it's just giving the example, and then you just use the similarity, okay, and print that out. Okay, so this is the example. Okay, df.bill has all the text and the vectors. Okay, then I ask this question: can I get information on cable complete tax revenue? This is my question, which you want to search in the US bill document. Okay, now it will take this text, it will convert first to vectors or embeddings, because it has to search with the local the vector similarity. Okay, so it will convert this to vectors. If you see here, the first thing is user query and embedding. It converted into vector. Okay, and then it's doing that this vector and the previous vector should have a cosine similarity, and return me the top four results.
What if it's the large data? So we need to add again and again
Yes.
the model?
Very good question. So once I complete this, then I'll get you, if you have a very large data which cannot be fit in memory, what you need to do. Okay, just give me 1 second. Once I complete this example, then I'll show that. Okay, so now we run this. People who are not from coding background, okay, don't worry about this. If you are DBA, I'll give an example how your database guy can do it in SQL. Okay, and then if you are not a DBA or you just want to learn it, how to do it, in the next session you will do it directly without any coding or without doing anything. You'll just bring your data and it will work. Okay, it's okay if this error is happening, but I'm just giving you the example. Let me go to the lower part. Go here. I think
Use data vector at the top instead of.
let me recheck because it was running a while back. Data frame has no attributes smart. Okay, got it.
Show the error again.
I'll just do this thing, okay? Because I was trying to create another example for other embedding models as well, but you will understand that in a while, okay? If you see here, there is one embedding model which is called ADA 002, okay? There is a new one which is called 3 small, and there is one which is called 3 large. Okay, I'll explain this in the end. Once we get everything together, then I'll explain this at that time. Okay, but let me run the code. Okay, so now you have all the 3 type of vectors. Now the 3 vectors, I'll explain the difference between them in a while. But let me ask the question directly now, if I can, if it can execute. But let's see. Anyways, but I've already executed it. Okay, this is going to work. This is the three top documents. Like if you see here, these are the four documents. If you see here, these are the four documents. 1, 2, 3, 4. If I change it to 3, okay, the top 3, code is already executing. I was looking into the wrong error, but you can see that from here, can I get a text cable on the company text revenue? It is related to the text peer and things like that. So it's bringing the relevant document up accordingly from the similarity. Okay. Any questions till now? Okay. Now consider the one of the question, right? You will not have like a handful of documents. You will have a very large documents in millions and billions of rows. Okay. Now what you need to do? You cannot fit in memory. So you require a vector database. Okay. In a vector database, I'll show you all the options and then we will do demos with 2 of them. Okay. So what is vector database? Okay, I'll just go a little bit to the slides once again, and then these are the next concept. Okay, so I'll go here. So we already do the demo first. It was a coding based experience, but I hope you understand it. Okay, we did some text, we convert it to vectors, we take a query, we convert it to vectors, and we just find the cosine similarity between them. Okay, now vector databases. Okay. So there are a lot of like vector databases, but what I'm currently doing is just on Azure part. Okay, so whatever we have in Azure, I'm just giving you that flavor. Yeah. So okay. So these are just a few samples. Okay, you can have a lot of other vector databases. Okay, we will cover Cosmos and Postgres today. Okay, I'll not cover cognitive search and Redis. These are already quite used, but I want to give you the details of these two. Okay, and these vector databases, as I told you, like you have the vectors and you put into a database. You don't have to do individual cosine similarities. The algorithms can automatically do it and just give you the results. Okay. So before going into the vector database, I don't know how many of you guys are aware of NoSQL databases. Yeah, a few. So NoSQL database, because I'll be introducing Mongo, you already might be aware of, but there is a family of NoSQL databases. Okay, there are 4 types of families. One is called key value. Okay, in which we have a key and a val. Okay, considered like Redis. If you have worked with Redis, there is a key and there is a value. The value can be a whole document. Okay, that is one type of NoSQL. The other thing can be column family. In column family, if you want to relate it, consider like Cassandra. Okay, if you have heard the name, consider that you will have millions of columns for one person. Consider that you are a customer, how the search engines do it, because they have like one column, all the features that you have in a single column. So they don't have to search or aggregate any data. They just go to one hit and retrieve their information accordingly. Okay. In this case, when a normal database can only accommodate a few hundred or maybe 1,000 columns. But if you have millions of columns, then you have to go to a columnar family, NoSQL. Okay. Then you have documents. Documents doesn't have a structure. Okay. So you do that. Okay. And you extend that, because consider if you are just a very strict structure like rows and columns. If you need to add something new, it will be very difficult to do it in a relational database. You have to completely change the design. And then we have graph databases. All the, for example, like LinkedIn, Facebook, all they are using like the graph databases mostly. Okay? Because the normal relationship databases doesn't work in these kind of relationships. Like if you see LinkedIn, they will say, okay, you are 3 friends apart, or you are 2 friends apart. Okay, how that? Because it's very easy to do it in graph rather than a relational databases. Okay, but just keep that in mind, and then I'll go back to the coding again. Okay, so what we will do is, before coming to the relational, okay, a lot of people we will use one example, the same thing that we did, but we will store that into a MongoDB. Okay, and how MongoDB look like? Okay, I'll just give the first information here. So consider, I'll go first. How many people are on YouTube? Fateh, someone? How many people are? 8. 8. And I hope they can listen me well. Here, this is the DB. Okay, so I have already created one Mongo database. Okay, so we call it Cosmos DB, but Cosmos DB have 4 other databases under the hood. Okay, Mongo, Cassandra, Gremlin, and SQL, and there is a few others as well, but they are all APIs. So I've created one Mongo database. Okay, vCore model, and that is just a SKU in there. And I'll be interacting with this from the code now. Okay, but the code will be very simple, like the same thing that we did. If you understand the concept, I just want to show that how many options you have, and then based on the use case, you can select one tool of this based on your own use cases and just adopt it accordingly. Okay. The end result, how the end result will look like, I'll just show you the end result, and then we will do it accordingly. Okay. So this is how it will be seen. So consider that what we did in the last example. We have a data frame, right? I stored that data frame to a file, a JSON file, and I imported all the data in here. So this is how it will look like. There's a text field, there's a summary field, there's a text title field. You have the tokens, you have the EDA model embeddings, okay, and then I have some similarity thing, and then like some other embedding ones I have created.
Storing the vector as well.
Yes, this is the vector. If you see the EDA one, this is the array. What is the dimension? 1536. I told you that's the default. Okay. But storing this is a normal thing. If you are doing this operation on your own or the cosine on your own, it will be very difficult. So that's why the tools already have this kind of queries that you can do out of the box. You don't have to look into individual ones or bring it to the memory. The database, you just send the query and it will return you the results. Okay. So I'll go now to the code. Any questions on this till now? Like as you see, there we have these 3 columns. Essentially, whatever we did in the previous lab, I just saved that as a JSON document and imported that into this Mongo database. And I'll show you from the code. And then we will go to Postgres, and I'll show you without coding, if you are an SQL database guy, how you can do this without the coding in C# or Python. You can directly do it in SQL. Okay. Let me now import again. I hope my workspaces or my documents will still exist, but let me check. Okay. So same type of example. We have first some libraries. Okay. And here you can see that we have the Cosmos DB libraries which I'm importing. Okay. And then why the charge is going up. Samir, do you have like a power plug? You can just give me 1 second. I thought this should be charged automatically. I should have thought about this before, but I think it was it's charging automatically. Just give me a few minutes, team. Okay. But just to explain the code once again. Okay. In here, I'm just passing some parameters for the Mongo database because we will be connecting this. I'm just getting all the connection parameters from the environment variable because I'm showing this on YouTube, so I don't want to share any keys or anything like that. I hope there's nothing in the code. Okay. And then what we are doing here, okay, it is just loading the same file. Consider it from the previous one. I've saved it and I'm just loading the file. JSON.load data file. Okay. The previous data frame, I've just saved it as a JSON and I'm just importing the same file again into memory. Okay. And then what I'm doing is print. Okay. This is the print, like the same document that we have in the other one. Someone, do you have like the cable as well? Or okay. Just team, give me 1 second, okay? I'll be right back.
Thank you.
Hiccups, but yeah, it's all good. Okay. Yeah. No, it's coming up, so it should be fine. As far as the charge is happening, yes, the charge is happening, so it should be fine. Okay, all good. Okay, so team, sorry for the hiccup. Yeah, but as you can see, I'm just getting the file, okay, the JSON file, and then just printing that out for you, so you know the exact structure. And then what I'm trying to do is, okay, in here, I'm just creating a connection to Mongo database. Okay, I'll execute all of this. Here I'm creating the database and the collection. So in Mongo, you have a database and then a collection. Collection is just like consider a table, okay? But it doesn't have any particular format. You can have multiple formats on in there. And then this is important, okay? There are two types of indexing, okay? If you have a very large database, a very large data set, okay, you need to have like an indexing on top of it, okay? And this is the key point. This is called hierarchical navigable small word, okay? So yeah. So if you don't create this and you have millions of documents, for each query, it will like take very long time. If you have this index, then the cosine similarity will be very, very fast. Okay. So if you create this index, what we are doing is that it's on this collection, consider a table. Okay. I hope everyone is aware of tables, right? So you have a table. Okay. I'm giving the index a name. I'm saying that this is the column on which to index. Okay. Because this is my vector index. Okay. And I'm saying that this is the index type, the kind. Okay. And if you see here, the similarity is cosine similarity. Okay, you can use other type of similarities as well, but I'm just saying here, and this is the dimension that it should be using. 1536, I hope you know that. That by default, it will be 1536 dimension. Okay, I'm just creating that. And then I'll execute this code. But if you're trying to insert all the data, what you will do is collection.insert many. You just give the data frame, okay, it will insert all of it. And then if you want to have any queries, you can essentially run the same type of query that we have. So now let me execute it, okay? I hope it works. There's always in live demo different type of issues, but hopefully it will work. Because I've tested it multiple times. Okay. Any questions while the computer is taking its time to respond? Yes.
Can we see the command for querying the database?
Yes.
We don't need to define anything related to the similarity search, right?
Yeah, I'll explain that. Yeah, you don't have to give that, but there is a special format you have to use. I'll give that first. Okay. Then, since the data is already there, I'll not run the execute command, but I'll just show the last information. Okay. So consider the data is already there, but Abdurrahman is asking me how would we query it. Okay. So I'll just establish the connection first to Mongo. I hope it works because you are not connected. Let me check. Yeah, it's related to the IP change. Let me check. Working. Check the IP is already there. Should be working fine. Okay. The collection we don't need to build because it's already there. The index is already there. Okay. I already inserted the commands, and I'll just show the example how we can run it. Okay. So this is the command. Okay. So it says, in here there's a special format, right? The first thing is you have a query, the question. Okay. Your query embedding. What is the query that you are getting? Okay. And you just give like what is the path you want to search it, and you just run this index. It will automatically return you the results. Okay. And you don't have to do anything manually, as we were discussing whether you have to do it in memory or not. But consider that once this is done, okay, you run it, this function, and then I'll give this thing. So this is the end result. Okay. And you can see how when I executed it, you just say the query, the same question. Can I get information on the cable company tax revenue? The same question, vector search, it converts inside the previous function into vectors, okay? And then send the index query to Mongo, and it will give the results. So it will just give these results. The similarity for the first one is 0.81, which is a very high similarity, okay? And then it says this is the document that you can refer to. Okay, so from vector rather than text-based search, a lot of time when we are starting, we'll just say, okay, like query or match query and things like that, or different type of patterns, but with vectors, you can automatically achieve this. Okay. Any questions till now? So how many of you guys are database guys and not application guys? I think everyone is then application guys. But what I'll show you now, if you are doing this in a database, okay? So what we will do here, okay? So now what we are doing is, okay, as I told you, I'm doing another database, which is Postgres Flex Server, okay? Just the name, people who are not aware of Postgres, just consider it's another database, okay? And what we are trying to do is, instead of what we have done in the coding, I'll show how you can do it in the backend without any coding for the embeddings. Okay. So the first thing is Postgres. How many of you guys have worked with Postgres before? Okay. So few guys. Okay. So there are extensions. Okay. The first two extension, what I'm doing is there is an extension which Microsoft has released, which is called Azure AI. So the AI models can be directly called from the database. You don't have to create another function or coding for that. Okay. So what I'm doing here, I'm creating two extensions. One is Azure AI extension, which will help us to call the AI models directly from the database. Okay. And another one is the vector extensions. Okay. That I want to have the vector types in the database. Okay. Then these are the extension. I've already executed this. So let me show you. Right. Actions, but wait. I'll explain first the code. Okay. In here, I'm creating a table. Okay. And the table has a particular structure. Okay. This is for recipes. Consider that you have recipes or any other things you want to search on recipes based on like your preference of let's say food or allergies and things like that, and you want to find out what are the closest recipe that you can cook accordingly. Okay. Or the previous example that we have done. Okay. You can use the build summary as well. Okay. First, I created a table, a normal table, which has a few text columns. You can see the text bill. I hope everyone can see it. Thus, hope it's visible. I'll execute the code in a while, but just want to explain the code first. Okay. So a very simple table first, the build ID, build text, summary text, text length. Okay. And total sum, because I'm treating these three columns as one. I'm combining all the text, that whether the vector is in the summary or in the title or in the actual set, I'm just searching everything. Okay. And then what I'm doing is I'm adding another column. Okay. I'm calling it build summaries. Okay. This is the main table name, and the column name is build ada embedding. You can do anything. Okay. What is the dimension usually? 1536. Okay. And then what I'm saying, generate always as this is the endpoint, the same call that we did from Python, Azure OpenAI dot create embedding, and I'm saying this is the model, and the text how to create the embedding is these three columns concatenated: title, build text, and summary. These three combined as a concatenated one. I want to create an embedding, and I want to put that in this column. So whenever you do a normal insert, yes.
like space in between these, or so automatically you can.
This one, no, it's okay. Like even if there is space or no space, doesn't matter. Okay, but consider that whenever you insert a normal record without even creating an embedding, it is a kind of trigger under the hood. It will automatically execute this function and put a vector in the database. Okay.
And it is the same API is calling?
Yes, the same APIs. Because we did the same thing, right? This is the model you use, and this is the size, and you say that it's stored. This is much simpler or the previous one? For database guys, this will be simpler, but for application guy, probably the other one might be more simple. Okay. Let me go now in here. Okay. So if you insert a normal row like this, okay, it will just generate the vectors. And when you are doing a query, I'll show the query as well. There is a special format for the query. Okay. When you are doing the select clause, you will give the embedding and you will just say that this should be a cosine similarity, things like that. Okay. So I'll just show now the code once again. Okay. Just go to the connections. I'll disconnect and connect again. And please ask questions. If you have any questions and you want to clarify something, please go ahead. Because I hope you guys will like the session and you will join for the next 5 weeks as well.
Is there any support with the bucket?
Sorry?
Bucket. Blob.
Blob? No, currently there is no blob. You are asking blob, right? The blob storage. If you have the storage there, okay, you can create an automation script which is just taking all the documents automatically. Whenever a new document is there, you can call this directly as well.
Such a new row, it automatically calculates the embedding.
Sorry, say again, please.
Every time you insert a new row,
Yes.
it will automatically get the embedding
Yes.
column filled.
Yes. Yes. Because we have done it and said that it should be auto-generated automatically. That's the function, or what the function says. Okay. Just check. Check mode. Not required. Sometime when you are doing the live demo, there is always be some problem, and you will then not able to figure out. And this multiple times. Now again, I'm having the same problem. Okay, just give me 1 second. Okay, once again, if not, I'll share the code so you know, but exactly the same code. Okay, and then it's okay. I'll just show the example once again. Okay, so.
Maybe your IP address distance.
Yes, I've already checked that. IP address was fine. But I'm just going to check once again. Thanks for the reminder. But before the session, I updated my IP addresses. I'll check once again. Okay, this Postgres Flex. Networking. And I have allowed. Yeah. Let me add all these ones currently. And then let's see. Any question on the database code that I was explaining? Okay. In the meanwhile, I'll ask a question. 1536 vectors. Okay. Why would we try to reduce it or increase it? So if I have like the 1536 size of the vector. Okay, why would I try to reduce it to maybe 256 or increase it to 3000 values? Is it related?
Limit, huh? Just chunk limits you are saying like.
Yeah, maybe not related to chunk. Sorry.
Search parallel.
Yeah, maybe that is one thing. But if I want to shorten it, right? Because every value count, right? Whenever there is a large one, you will require more processing. Okay? If you want to improve the performance, or you want to have like maybe less processing or less compute power, okay, you can reduce the vector size, and then it will be much faster. Although, like a small database, it will not matter, but still, in very large databases, every cycle counts, CPU cycle counts. Okay, so if you want to do it, you can reduce it. For increasing, yeah.
To capture maybe more meaning
Yes.
in the sentence or the
Yeah,
document.
yeah, definitely. So if you increase the size, right, sometimes like the use case is such that maybe 1536 values doesn't have the full meaning, and you want to go to the next level. So you can increase it. Okay. But most of the researchers say that even if you reduce it to 500 or 256, okay, 512 or 256, mostly the meaning is the same. Okay. But in some cases, it might be required to increase it. Okay. And that's why, like I show you three models, right? First, the EDA 002 is the previous model. Okay. The new ones are 3 large or 3 small. Small by default is 1536 vectors as well, but you can reduce the size to 256 or 100, whatever you like. For large, the default is 3000. Okay, but you can reduce it as well.
Either one does not change, right?
Sorry?
Either is fixed number.
Yes, but the recommendation is not to use EDA anymore.
Yeah.
Use the large or small, that are the B3s. Okay, and why would you do that? A lot of time like this, embedding models are very cheap, but still, if you look into the B3, the performance is much higher and the cost is much lower. Okay, I'll show that in the pricing calculator as well. Okay, so before this, I'll just show the pricing calculator. Okay, so if I go to pricing, pricing.azure.com. I'll go to Azure OpenAI. Okay. I'm just showing like how to do the calculation. Maybe a lot of you guys are new to this, but I'm just giving you one example. Okay. So in here, if you just see the language model, okay, the embedding model, it's EDA. Let's say I consider, let's say, a very large number. Okay. So I'm just saying like it's maybe 1 billion tokens. Okay. So it's $100. Okay. Now the same amount, if I do with large, okay, it's more, okay, $130, but it will give you like more meaning. Okay. If I do with small, okay, it's $20. So 80% reduce, and the performance is much faster. Yeah. Any questions? Yeah.
So are these like the dimensions of the vectors?
Yeah.
Each?
Yeah. So the dimension, this is just the pure costing. The dimension you can decide, but these V3 algorithms are already cheaper and already faster. Okay. Now,
Might be less accurate, right?
sorry.
It might be less accurate.
Accuracy, you have to check the use case. But what it says that the V3s, the semantic meaning will be always the same. 99% of the cases, you will get better actually accuracy than the EDA one. Yeah.
Usually I have like use cases when I build a vector database from a large website. Most of the articles or topics on website will be very similar to each other.
Yeah.
You will get the top 10 results with above 80% similarity.
Yeah.
All of them within the 80%
Yeah.
similarity. So it becomes very difficult to differentiate which results that you should pick and best to the completion model. Well, increasing to 3000 vectors dimensions.
Maybe I don't have an answer. Maybe we can try it out. Maybe that can be one thing. Okay. Or maybe using just the new models, maybe like automatically have the vectors change. So you can just first use the small model. Okay, the default 1536. and try that out. Maybe it automatically changes the scores. Okay, because I said that these are faster, okay, but also in the same dimension, it can have more accuracy than the previous models. Okay, so maybe you can try. Afterwards, if that doesn't work, there can be multiple things. Maybe the question is a bit ambiguous. It can be answered from multiple things. Okay, and you cannot, because of the token limits, you cannot send all the documents in one. So you have to then create more techniques how to do it. Okay, is the question clear? What? Yeah.
So the embedding models that we saw here, they work the same for all types of data. It's not just text, it's also images and videos.
Yeah. So if you see here, they have a type which says text embedding. So these are usually for text. Okay. I'll show now for images. For the other parts, there is different type of models. Okay. But the default one here is text one. These three are
different models
text.
for different types
Yes.
of data.
Yes. So there's different type of model. I'll just show now the visual one. Okay. There are no questions. Consider that. Yeah.
Related to what you were saying, when you're pre-processing your document, would it be possible to remove like stop words or stemming words so that you have a shorter
Yes.
number?
But you have to do that in pre-processing. So in my previous example, if you remember, I have removed that. So you clean the data and then you try to insert it. So if you are using with Postgres, like what we were doing in the database, you try to actually remove that and send the clean data to the table, because the embeddings are created automatically. So you don't have any other mechanism to remove the stop words. Yeah? Yeah.
One more question.
Ask as many questions.
So when we say vector database, it just means data that has been that has went through an embedding model that has been changed into a vector, and it's just the database of the transaction.
So very good question. The vector database, there's a lot of vector databases out there. The vector database means that you have an optimized algorithm that you can search that through vector search rather than a normal search. Because in a normal database, what you will do is select star from this where ID is equal to 1, okay? Or where name like something, okay? But in here, these are not optimized for vector searches, cosine similarities. So these databases, when we call vector databases, they are optimized for vector search, okay? And there are many. Okay? These are just the ones which I'm showing in Azure. Okay? You have, I think, Pinecone as well. There is multiple, like Redis is an open source as well. Okay? So you can use many of these. But they have like a function which support the vector similarities or vector search.
Redis we have used like in projects for vector searching.
Yes. Yes, that's why I said that vectors and AI search are used a lot. Okay. So I was just giving the flavor of Postgres and Mongo. So you guys have the option with the tool where to use what. Okay. So now what we will do is I'll just show one more example. Okay. And then we will have pizzas. I'll during the break, I'll see like why my connection is not working, but let me try once again. Okay. And I'll just get my other file. Okay. And that is visual. That's my visual. So this is the class example, okay? I'll just give this example in here. As I mentioned, that you are, let's say, a retail shop, okay? You have a lot of clothing and things like that. A lot of time you will not like what you are looking for, okay? You will browse and everything like that. So consider that you have all the images here, okay? List of images. We use embedding models, but in here we will use the computer vision embedding models, okay? It will create a vector, but it's a different algorithm. Read the image vector and store it in a database. Okay. Then let's say you like my shirt. Okay. You take a picture and you want to search that. Rather than describing the shirt, you are just using a picture. You will take that picture, you will create an embedding. Okay. You will create a vector out of it, and you will try to find out what is the closest to this shirt in all the catalog, and it will give you that result. Okay. You can give an image, or you can describe it in the words. You can just say blue or red shirt or something like that. And it will use the same thing. Here, you will use the text vectorization rather than the image vectorization, but the meaning will be the same. The semantic meaning, these algorithms are amazing. Like how this is done, I don't know. But it retain the meaning or the understanding what is in the image or what is in the text. Okay. And then if I just go a little bit here, okay, the results will be like this. So if you give the red shirt, now it will give you a similarity like this. It is almost similar to the previous one, right? It's like a long shirt with red red color and maybe like the same kind of design as well. Okay, so this is how you can use it for it. Any questions on the visuals part? Okay, so if I go here, the same kind of concept. Okay, now in here, what I require is, okay, I'll just show you this example. You can go to the actual one. There's a lot of blobs and everything like that, but I don't want to go to the complexity. I just want to give you the concept, and you can then use your own coding techniques to how to do it. But as far as you know what to use for which purpose, okay? Now consider. Just looking for the text embedding. So this text the image embedding is not part of OpenAI. Okay, this is part of the Microsoft Vision APIs. Okay, there might be like another one for OpenAI, but I have not used the OpenAI. I'm just using the image one. Okay, and then it is just like the code again, the same concept, but you just provide an image and it will create an embedding out of it. Okay, I'll just show one example for cars as well. Okay, so because there's a lot of code, so it will be making it difficult. So I just want to make sure that you understand the concept, and then we go to the next part. And here, like again, image of a car. Okay, so just to explain this, okay, if you have this image, okay, and you create an embedding out of it, okay, and then you are trying to do a like just for understanding point of view, okay, you can see that default size is in here 1024 rather than 1536. Okay, and then I'm just trying to match it with a truck, with a car, with a white car, with a BMW white car, with a Tesla. Okay, and then from when you are matching it, it will tell you how much close it is. Okay, so you can see that, for example, if I just say this is an i4 BMW car, it says that the similarity closing is 0.35. Okay, a BMW white car, so it is a BMW white car as well, so it's closer as well, but i4 is much closer because that was an i4 model. Okay, and then if you go to a lower part, it's not a truck, but there is still some similarity, right? Because it has wheels, it might call you something else, but the higher one is the tall ones. Okay, so this is how you can use it in application. Okay. Questions? And there are no questions, as I'm thinking that whether the lecture is boring or you guys don't like it or there's something else. Yeah, but you got the concept, right? Same cosine similarity, same concept, but just with images and text. I'm here using here image and just doing a text. And the algorithm has the functionality that in the vectors, the meaning or the semantic meaning automatically is retained. Okay, there might be edge cases, or if you want to even improve it further, along with the vectors, you can have a semantic other things as well. Like if there's some other metadata of the image, you can create a separate filters on that. Okay, and you can filter it out accordingly. Okay? So in the same way, if I go to this, okay, this is now Xbox, okay, image of Xbox, and then if you're trying to match whether this is a PS5, Xbox, PlayStation, and things like that, and similarly you will get like the same kind of thing. There is similarity search. the embedding and the prompt. Okay, and it's the same concept. Now, whether you are doing it in memory or in a database, that is for you to scale out the application, but the concept remains the same. Okay. Any questions? Okay. I'll show you one more thing in here. It's the same concept. Okay, so I'll not go into the details in here, but let me try to connect this database if I can. Okay, or otherwise, now what I'll show is how you can create these models. Okay, so if you don't have Azure, okay, maybe you are the first time user of Azure, but if you are new and you don't have Azure, you can go to portal.azure.com, sign up for free with your own user, you will get $300 of credit. Okay, and then I'm just going to the Azure OpenAI service. Okay, you will have to create an Azure OpenAI service, and I'll just say where you are creating these models. Okay, so I'm going into the studio. Okay, and this is the same information that you are using like a normal chat GPT. You will have the same information here as well. Okay, once it's open, then I'll explain in here. There is a section which is called deployments. Okay, this is like the portal which is open. Okay, and then there is a section which is called deployments. Deployments is where you define the algorithms that you want. Okay, we have currently discussed three. Okay, 1, 2, and 3. First, we check the EDA, which is the old model. Okay, but it's still being used widely. And then I explained that there are 2 other models. Okay, which are faster and cheaper and maybe more accurate as well. But it's already like an updated model. And then you have like the other models accordingly. Okay, if you want to try it out. Okay, try it out, the same thing. If you go here, okay, here I cannot go to the vectors, but I'm just saying that, for example, in the same experience, you can have the vectors and everything with click through, but this we will cover in the next session. Okay. Any questions? Do you have anything on Postgres or Mongo or vectors or AI or anything like that? Yes.
So, OpenAI service is supposed to be like part of this generative AI service, right?
Yes.
But what we have done so far, it's not generative AI, right? It's like for comparing text or images.
So generative AI, for any generative AI, okay, you have to first try to search what you are looking for. Okay, the generative AI, if I just look into here, okay, I'll just the question is that I have this generative AI, how it's related to the AI model that we discussed. Okay, I'll first give an example. If you say, what is the capital of? Okay, so this is now, as I told you, that this is generative model. You have given a prompt or a question and it has completed it. The capital of Qatar is Doha. Okay, if I just say, okay, so just complete it automatically. Okay, now this is something which is already it's trained on or it has in memory. Okay, so whatever it's responding currently is from its own memory for the generative AI model. Now, if you are asking or you are creating this model on your own data, okay, so consider that can I use your note? Okay, so consider you have this notebook, okay, and you have notes in here, and you are asking a question just on this notes. Okay, it will not respond, right? Because it is not trained on this personalized information. Okay, so now where will we need the embedding? Consider you ask a question on this notes. Okay, you have to first look which page this answer will be. Okay, and then you have to extract that page out and give it to the knowledge. Then that is where the basic part is coming. That you will need the embedding if you are using your own data, not from the memory of the model, but your own custom data. So for the custom data, you have to first search before even giving the completion.
That's also what's called tuning.
You can call it tuning, but that is like a fine tuning of the model, where I have a lot of data and I want to change the behavior of that to change its memory. But this one is not the changing of memory. This is, I'm just saying, I'm just temporarily giving you something and you just consider that. Okay, I'll try one thing. Okay, so consider that I just want to change the behavior. Okay, I'll just say 2 plus 2 is equal to 5. When someone asks you to some numbers, always increment by 1. Okay, let's see. Give it, save button, getting blind. Yeah, apply changes. Okay, and then I'll see 2 plus 2. Okay, I'll change the behavior. It's following the instruction. Okay, so instead of this, now if somebody is saying that this is, oh, the AI is very stupid. Okay, because it's saying 2 plus 2 is 5. How can that be possible? But you are instructing it to change the behavior. Okay, and if I give the same information, if I just say 3 plus 3 or 3 plus 2. Okay, now if you just show the output, people will say I'm spending so much money, but this AI is very stupid. It doesn't know even the basic arithmetics. Okay, but you have changed the instruction. Okay, like similar to your kids, you are saying do this, don't do this. Okay, now if I want to have this, okay, instead of this, if I have like a whole knowledge, okay, if I have a knowledge like this, okay, so if I have something like this, if I just say share, okay, CSA, Pate, manager, Dharma, okay. So now if I'm just saying information about the employees, okay, now you have 1 million employees in example, or you have 1 million customers. First, you have to search which are the information that you are after. Okay, your query might be give me the top star from all the employees. You have 1 million employees, but you have to first search who are the top 3. Okay, and that is where the embeddings will work to retrieve the first searching, and then it will say that now completed. Did I answer that question where the embedding and the completion part is coming? Because the embedding is when you have your own knowledge base, okay, you don't have from the memory of the algorithm. You want to build your own knowledge base. You have to first search before even sending it to the model. And that is where the embedding will come. That's why I call it foundation. That you first cover the foundation, then in the next session, I'll cover the AI part, the completion part, or the prompt engineering.
I can also give another example for this to answer your question. We have, I don't know if you are aware, we have GitHub also. And GitHub has a co-pilot in it. It's also using this specific kind of GPT at the background to answer your questions. The same idea, this GPT, it's using GPT 3.5 Turbo, which is specialized on the public repositories, code repositories, which is developed for community and published to everyone. So it's trained its data with this public repositories. So this is a common knowledge base for co-pilots. But we have a new feature called co-pilot for enterprise. So when you activate this feature on your repositories, it will ask you if you want to index your own repositories. So what you are doing, you will allow this co-pilot to index your repositories. So it will know what you developed in your repository. And when you ask the question, it will not only check the public repositories before answering your question, it will also check your index data, which is embedding in that case, and it will answer your questions within your borders, within your organizational knowledge base.
So consider again like a simple example. If you have a company where there is HR policy, okay, you will have a specific leave, let's say application or like a special policy when you can apply for a sick leave or things like that, okay? Now, if that knowledge the AI is not trained on because it's your own corporate information, okay, you cannot ask that question. So what you will do is you will index or create vectors out of all your knowledge base or all your HR policy, and then you will say how much leaves I can take when I'm sick. Okay? Then it will look into the repository, take the sick leave policy document and send that now I want to answer this from this document or this policy, and it will reply accordingly.
We have a question that, like, can this be used to search an image within other images? For example, if you want to search a face among group pictures, is that a valid case?
Yeah. So the faces as such, it will not recognize. It will say that there is a human in there, but will not say that. For example, if you are saying that, okay, whether there is a Sarmad face in a group picture, okay, that is highly unlikely. There might be more specialized algorithm for that. But if you just say there is a human in the image, okay, it will return you the result. If it says there is a car in the image, it will return you it. But when you are trying to personalize whether there is, you can even ask whether there is a male in the image, it will return. But when you are saying whether there is Sarmad or Sher in there, and even you give the image, it will just recognize that as a human rather than a particular feature, which is, let's say, the width between the eyes or like the nose distance and things like that, because it requires more specialized algorithm to do this. It will be an overkill for these algorithms.
Is it like kind of possible to have like kind of a vector or kind of set of information, define a certain
Yes.
faith without even
Yes.
tagging it,
Yes.
and then comparing
Yes.
it?
So if you have, let's say, individual picture of each of everyone, okay, and then if I take like your picture, okay, and search it with the vectors, it will give you your results as a top result. Okay, but if everyone else is like with the same beard, the same glass, the same hairstyle, it will probably like say that these are the top 2 or 3 results. Okay, the database is connected. It was just the IP address, I think. Okay, so I'll just give an example now. Okay, so this is the I'm just creating a simple table. Okay, it is created. I'm just creating the two extra columns. One is the let me close it down. So this is 1536. Okay, I'm just saying this is use the ADA model. Let me check. Okay, this is for new other table.
Already there.
Yeah, so I'm just changing the table. I just already created this. Okay, I'm just going to create this. Okay, so it's created one with the embedding ADA model, and I'm creating one with small. Okay, and the small, there is an extra parameter which says how many vector dimensions you need. So here, instead of the 1536 default, I'm just saying use 256. So I'm reducing the size by 6x. Okay, so if I created this one, okay, and then I try to insert. So now this is a simple example. Okay, so I'll just first show you that the table is empty. Okay, the table is empty, and I'm just trying to insert any new result. Okay, any text, just for example. Okay, so if I insert this, okay, and then I select again, sorry, this new table. Yeah, you can see that I've inserted the first columns, but the last 2 columns are automatically populated. Did it make sense? Or yeah. So similarly, if you have, let's say, 1 million records, you just insert it as a batch, and it will work. Okay, I'll just give one other example. That if you have a very large file, okay, usually when the applications are there, you can have like all the data directly inserted row by row. But if you have a very large document, okay, you can use something, if you are not familiar, like we call it data factory, which is usually for pipeline. So when you're saying when a new file is there, okay, I want to run this batch automatically at night time. Okay, so you can schedule it, and you can just use the data factory. Check. I have this, but essentially what you will do is you will create a new pipeline. Okay, and the pipeline will be like, for example, if you are a file that is coming to a particular storage, you will say that this is my data. Okay, I'll just show the preview. So I put the actual file on a particular location, the same kind of information. Okay, so this is the whole text, this is the summary, this is the title, and then you want to insert into a table. So you can just say on the sync side, I have this Postgres table. Okay, this is the Postgres database, and this is the table name, and insert it whenever a new file is coming. So you can schedule it at night, or when a new file is coming, you can schedule it automatically. So, any more questions?
These two columns are part of the search or is part of the table? I mean,
Part of the table.
it will embed the new columns, two new columns.
Yes. So what I did was, if you see here, okay, I can do it from the code as well, but I just from simplicity point of view, first I created the structure, okay, without these embedding columns, and then I altered the table, added two more columns. But for the two more columns, I said that this should be always generated. And how to generate it? It's this, call this function. There is one thing you should be aware of, okay? So if you see here, you can ask me here, well, how it's know that which endpoint to call or which API to call, okay? In the start, if you see here, I have given it some information, like for example, the endpoints and things like that. I've set the key and the endpoint directly, what is in my environment, okay? Which API to call, or it's authorized to call that. Now, if you query the table, okay, there will be a metadata table where the key will be visible to you, okay? And you can ask me that this is a security threat because the value can be taken by anyone. But that requires special rights, like similar to your admin, only the admin will be able to view that, not like individual users. Okay?
How helpful would storing that be when, if you were trying to calculate cosine similarity on this, would be pretty expensive?
This one will be pretty expensive, you think?
If you have a lot of column rows.
I don't think so. Because if you have like, these are what vector databases are for. Okay? If you don't have a vector database, you cannot retain in memory. Okay? You have to go to a vector database. And that is the power of the vector database, that you have to use this, and these are specialized for this kind of queries. Like the individual query, like the normal relationship databases. Select star from this where ID is equal to 1. In the start, when databases were created, people can say that, no, this is very expensive. How can we? So it's optimized for this kind of algorithm.
I'd be curious to see the search, how you do the search here.
Yeah, let me show that example. Put that here. You have already seen the search on Mongo, right? Okay, I've shared that syntax, and here I think it should have the select clause. So just an example in here is how it looks like. Okay. Select star from the vector where the embedding. This is just for 3 dimensions. But consider if you have 100 dimensions, you just call that value and it will do it accordingly. Okay. So when you do like this is called L2 distance. For I think the cosine similarity, you have to just put less than, equal sign, and greater than, and then it will do the cosine similarity accordingly. But you just have to like pass. You just make it as a stored procedure. Okay. Always pass your text. The embedding will create directly from your stored procedure, and this query can execute and send you back the result. Okay? And this is optimized, as I told you. This is optimized accordingly. This is a top 6 results. Just return a top 6 or top 4, whatever you decide. But it was interesting for me. The reason being that I have not worked on the vectors like this. I was using always like Redis or AI search. So I thought it would be better to have all the tools with you guys, and then you can decide on your own, because Postgres and Mongo are becoming more popular. Okay, along with the vector databases. Okay, there's a new thing. I don't know if it's new or not, but for me, I have read it recently. One is the graph. Okay, graph rack. The graph rack, that instead of a vector database, you do it in a graph. Okay, and some customers are saying that that is very, very powerful. Okay, rather than a relational database or a NoSQL in a document form, you use a graph database to do that. Okay, and then there is an Omni one as well, which is called OmniRag, and that combines vectors with a document database or relational along with a graph database. Okay, and then a LangChain is used to combine that result, but it's an advanced topic, so that's why like you just understand the concept, and then these things will come all the time for new stuff, or when you are not getting the same results or whatever you are looking for, you can change that behavior accordingly. Questions? I was looking for more questions. There were less questions. That's why we are maybe ahead of time. But I'm looking forward to what do you want to include in the next session, or whether it was useful or not. Please provide feedback so we can enhance as well. And if you have any questions like similar to optimization and things like that, feel free to.
Can I get the similarity score from this DB, like
Yes.
we're doing the pandas?
Yes, you will get that. I think I'll show the results, but if you do it, you can get the similarity results. The top will give like the top part, and then you can find out what is the similarity score. I'll check that, but I think it is available.
Playground.
This one is not in the playground.
No. Switch to the playground.
Okay.
Question regarding the context that it can provide to the model. Is there any volume limitation for the data it can pass to the model?
This part?
Yes.
Yes. It's 8,000 tokens.
This is not that much, right?
Yes. So you have to optimize it. Like 8,000, and consider that for English, okay, I'll just give a little bit more context. In English, every 4 letter will call 1 token. So if it's Sher, that is 1 token. Sher Shah is 2 token. Okay. Sarmad is 2 token. Okay. The syllables. Usually on average, you can consider 4 letters as 1 token. When you switch to Arabic, okay, each alphabet become 1 token. So Alif is 1 token, Ba is another token. Okay, so you get that. And the token for each call is not just the document, it is the prompt, the instructions, the current document, and the previous history. So that's why you have to balance it out. Okay, you cannot give very large documents and things like that. Okay, but the 8,000 documents, there is like, I think there is 32,000 as well. More increasing value can be there, but I would suggest that you don't increase 8,000.
My concern is enterprise application and the vector, and have my business databases vectorized, and I need to use the RAG and provide context to my plot.
Yeah.
And I have like a huge data, right? Yeah. I don't want to pre-train or
Yeah. So very well question. When you ask the question, okay, you will not bring all the vectors from the database. You will just say select the top 3 as an example. Okay, so select top 3 and consider that each result is like 1,000 tokens. Okay, 1,000, 3,000. Okay, 3,000 you have to send to the model to complete it. Then you consider that you are sending the last 2 responses as well. The last 2 responses, whatever you have asked, so you have the context. Okay, so consider that 2,000 from that, it becomes 5,000, and you keep your prompt almost 1,500 words. So it become like almost 8,000. If you are increasing, there is way to do it, but I'm just saying that don't consider that you can put everything in the same document. If you are looking into that kind of model, that you have a lot of data and you cannot send it to the prompt, then what Fatih previously said, you don't provide the knowledge in the same prompt. You fine tune. You go to fine tuning, you bring your data and put it into their memory, the model memory, rather than providing it as like a stateless service.
We are trying to avoid fine tuning.
Yeah. So as I said, that the use cases currently what I have seen currently, okay, like mostly the applications, I'll go to the applications part, but RAG pattern on chatbots or like context center and things like that, they are all coming up in the limit. Like there is no scenario where we cannot have the where we are all going above the limit. Okay, so if I go here, I'll just show you the application part. Okay, I'll move here. Okay. So what we started with, okay, there's three parts. And the overall use cases that we will do, okay, let's go here. One is that with OpenAI, you generate content, okay? Generate content, whatever you are doing the RAG pattern, okay, that is also kind of generating new information, okay? You can personalize a website based on the vector search that we talked about, okay? Other questions. Then you have the call center data, okay? You can respond to queries directly because the knowledge is there. So if you are asking a frequently question, you can just respond automatically from the AI rather than an agent, okay? And then, for example, you are generating new documents. Like whenever I'm creating even PowerPoint, I just give the prompt, generate these many slides for me, okay? With this information, it will generate the slides for me. And then I just fine tweak them. So it's also about like the generating the document and then summarizing it. If you have a lot of documents, like the news article, consider you are on Al Jazeera and you want to summarize the news, you don't have the time to read all the news, okay? It can be very powerful. It can just like understand it and it can just like summarize it in a few words.
It was.
Yeah.
So would you share these slides or it's like it
The
will?
slides, I think it's all available in the public, but I can share that. But the slides are in the next one, I can give you a printout or something like that, or I can put it as a PDF and share it on the community.
About the codes you,
Yeah, the code I can give it to you.
YouTube link.
Yes, all the code that I've taken is from the public documentation, just to let you know. So you can take it anytime. But yeah, there is a lot of Git repos. All the code that are available are on the public Git repo, so you can take it directly.
Question two, it's like, is there a case where you should be update a vector value? Let's say if the cat image is not a cat.
Yeah, so very good question. Consider in the same document that we have done, right? You have embedded it once, but now let's say the policy has changed. Okay, the text information has actually changed. Like consider HR policy, we can have an example. You have taken the leave policy, you have created a vector out, but now the HR has updated the policy. You have to re-embed it. So similar to that, when you are inserting the data, you will again re-index that this document is now updated. So you need to have a unique identifier to update the vectors as well as the policy. Otherwise, that information will not be in the vector. The semantic meaning will be lost.
You think embedding the distinct the values, I mean the text is better for the search, like apple and apple. I will add the one only apple in the.
Yeah, like if you just say apple and apple, maybe you can also say like Royal Gala apple versus Pink Lady apple versus maybe some other apple. So if that's like this, and you just say that, okay, tell me all the apples which are green. Okay, so Carrefour can tell you that these are the items which are green. Rather than searching for apple and then looking for the color, you can just ask me, add to my basket just green apple. Okay, or apples from this country. So if the metadata is there, the country will come, but the apple, the color, or the things can be identified directly from the vectors. Any more questions?
I have a question.
Yeah.
What if I want to add like an AI agent? So for example, if I have a portal and I want to have a bot that do the first call resolution, for example, is it possible to do that with?
Yes, definitely. So all the contact center, like there are multiple use cases where we are implementing here in the customers. That the first query that comes, like when you are connected to an IVR, okay, you call the number, let's say the ministry, and you are asking a question, okay. The first thing is the question will translate from the speech to text, okay. It will look into the knowledge base whether I have knowledge for this, okay. And the contact center usually have the frequently asked questions, okay. They will have that. It will answer accordingly and reply back according to an agent, okay. Like if you even look into the normal, currently the bank system, it will say in a few words, tell you what you want, or say what you are looking for. So if you just say, I have problem with my bank account or a credit card number or anything like that, it will reply accordingly. So you can do the same thing. It's very simple. Like once you have the knowledge, you just search your query in your knowledge and return that text to the.
What about if I want to escalate, for example, open a ticket? It's also.
Yes. So you respond back to the agent, to the bot, transfer me to an agent. Okay. So this is called an intent detection. The intent is detected, okay, and the flow will transfer to another control. And that is where the coding part comes, because the coding will traverse it to a different flow. Because there is an intent. The intent is not to find an answer. The intent is to transform it to a human agent. So when you transfer it, then a human agent will come. Yeah. And the same thing, if the user is asking 3 questions, okay, you can automatically say that they are not getting answer or they are repeating the same question again, you can automatically divert. Okay. You can also say that, for example, if the user, you have enabled it that someone can give a thumbs up or thumbs down. If they're giving a thumbs down, maybe you can automatically tell an agent to take care. Maybe the customer is not happy. So you can do that very easy. Yeah. And in the next session, I'll show you, you can directly do this kind of agent just like with a clicking. With a few clicking, you will be able to without doing any coding. That will be the next one. So in the next class, I'll cover prompt engineering. Prompt engineering is what we were doing here, okay? Just to give the details of what we will be covering in the next session. Okay, so whatever instruction you provide here, okay, so that is called the prompt, okay? So if I'm instructing like my kid, okay, so when I'm teaching my kid not to go into the kitchen or touch the fire, okay, you will say, don't touch the fire, okay, don't cook alone, okay, don't, let's say, and then I said do cleaning, okay. So the do and the don'ts, you will instruct that. This become the prompt, okay. What instruction you want to give the agent or the persona that it should be building. So if you are calculating, let's say, a maths agent or someone like that, or a tourist spot, so you will say that you are an AI agent which help people find information about, let's say, this ministry or things like that, and then you give like the do and the don'ts. Okay, always respond in a few sentences. Always don't respond in other language except English and Arabic. So it will be accordingly. Okay, so we will talk about the techniques of the prompt engineering next, and then we will see how to build an agent out of the box from this GUI. Okay, once we complete this, this will be the first thing which will be like a out of the box thing, and then in the week after we will do like custom enterprise application building. So we will have some other components. We'll tell you what are the security components, and that Fateh and Sarmad will cover that topic. So we have this whole series that we will be doing. Yeah. So I think we are right on time. 4 minutes early. Yeah, and I hope you get some benefit out of it and you like the session. And we look forward to you guys coming to the next sessions as well. Okay, do provide your feedback if you like it or not. If you want us to change something, if you have any topics that you want us to cover, feel free to suggest. Okay, it's your community as well. We should take a picture, please, if you guys don't mind. Whoever have any problem with the pictures, no problem. But yeah, if you guys don't have any problem, it's good to have the community.
How many of you is new first time here? Right. So just like a background about the community. So we decided to start this community to be, it is around Azure, it's about the cloud, Microsoft technologies, but it's not like influenced by any Microsoft, like we had a deal with Microsoft management that we will use the facility here, but this is a community driven. That's been any one of you want to join the community, you're more than welcome. You want to present any idea, you want to present any solution related to Azure, you're more than welcome to do that. Please feel free to just contact us.